This talk is about the work we have been doing within the SNB Interactive and BI task force, which is about the definition of the business intelligence workload and its choke point analysis. I will now explain what's that choke point analysis. So this is the team. I'm the task force leader, and these are my minions. Marcus, Moritz, and Alex. Where is Marcus? Is he hiding somewhere? Okay. Oh, come on. He will have to look at the video later. Okay. So a little bit of recap. In this task force, we have two workloads. One is interactive and one is one is the BI workload. The goal of interactive workload, which is published in the documentation, consists of the core of the workload are these 14 complex queries, which are queries to be complex, but at the same time interactive. And usually these queries consist of given starting point, a node in the graph, and then explore the surrounding of this node in the graph. It's user-oriented queries usually. In the case of BI, what we have is 25. I put here the question marks because we have still to decide whether this will be the final number or a smaller number. The goal of this workload is, as its name indicates, to have a set of business-oriented queries that, compared to interactive workload, touch a much larger amount of data of the graph and answer questions that are not focused on a single user, but are focused on the whole data set. One more citation. This is the last one, the previous one. Two. Presentation. Peter, are you sending emails while I'm presenting? Okay. Okay. So this is I will end up of time. This is the difference. Interactive, as its name indicates, interactive queries that can be sub-second or sub 2 seconds answered. Business intelligence, huge batch queries that touch a large amount of the graph. And this is the LDBC SNB algorithm, which is the algorithm we follow when we want to define a workload. We start with a candidate set of queries, which are both use case and choke point based. Choke point means specific aspects we want to test from the target system. For instance, its ability to optimize the join order of some query, or to apply the correct join operator, given the observed data, for instance. Then, given these queries, this set, what we do is to implement a set of validation set for cross-validation, which in the case of interactive includes an Sparksian and Neo4j dataset. In the case of BI, we have also included PostgreSQL into the set. Then, based on this implementation for cross-validation and our observations, what we do is to iterate this process, either because the definition is not clear. Sometimes definitions are ambiguous, and we spend. It's funny because usually Alex implements something, and Alex is very smart and never makes an error. So I end up spending 12 hours trying to back why my implementation is not correct. Then I realized that Alex interpreted the query in a different way than me. So I have spent 12 hours trying to find Alex's book, of course, because his was the wrong interpretation. So, of course, I'm the boss, and I always have the reason. Also, because the obtention of the substitution parameters might be difficult, or because a query can be gamed. There can be a very trivial trick that makes this query useless for the workload. And when everything is okay and we are happy, we publish the draft. So everything revolves around this table. This is the choke points table. So for each query, we have the choke points it fulfills. I will now show you some of the choke points. So every time we take a decision, either because we change a formulation or whatever, it's taken based on of this table because we want every choke point to be fulfilled by at least one query. The problem is that for the BI, we didn't have the choke points. The queries from the EU-funded project, the queries were created, I think, by Andre and Orri. So we received the choke points. So instead of asking them to provide the choke points, now they are working somewhere else. What we did, okay, let's start an analysis and try to identify all the choke points of the queries we received. So we patched the algorithm. So for each BI query, the first step what we do is to improve the formulation. So make sure that it's not ambiguous. And then find the choke points of that query. And when we have finished, remove the new queries, remove or add new queries if necessary, and publish the draft. So these are the queries we received from LDBC, 24 queries. As you can see, the titles are self-explanatory, like finding related topics, trending posts, experts in a, sorry?
Zombies in a country.
Yeah, zombies in a country, yes. So, yeah, I don't know what was Orri thinking about that day. So we take these queries. I show you an example, for instance, query 14, which is we want to find the top threat initiators. And I choose this query because this query has a graphic component. Because it asks for each person. It asks for the posts that created within a given interval and that have a number of message in their reply trees. Remember that before I talked about the message trees in the DataGen talk. So we look for messages that have a certain size of this tree, okay? And then do this counting in such a way that the result we find this person top threat initiators with some information, a sorting criteria and a limit. Okay, this is the general schema and of the queries of SNB workloads and the flavor of the BI workload queries. As you can see, parameters in this case do not specify an entry point in the graph like a specific person, but a date range. Typically, interactive queries have a person ID as an entry point. So the choke points analysis, we took the choke points we used during the European project, which are taken from this, are a mix of these two documents. Some of them are the ones used for interactive, and the other ones are taken from the. There is an overlap between these two documents. Choke points are classified in seven categories: aggregation performance, join performance, data access locality, expression calculation, subqueries, parallelism, and graph specifics. In total, I think there are 25 choke points. So now I do some data analytics one-on-one about the process. So and these are the results of the choke point analysis. It took 35 meetings to understand the queries because we are not, well, at least myself, I'm not an expert on query optimization, so I have to say I learned a lot with this. So it took 35 one-hour meetings to go all over the queries, where we identified a total of 146 choke points. This means a little bit about 4 choke points per hour. So It took choke point 40 every 10 hours. It looks better this way. It's about 0.7 queries per hour. I think it is even Sparksy goes faster, I think. In the process, we added 2 new choke points that were not present in the documents. Actually, those graphy choke points that are in green, the 7.4 and 7.5. We changed the definition and formulation of 10 queries, either by refining the wording or changing a little bit the query because we thought it was not complex enough. And we added an additional query, 25, which basically is an extension of interactive query 1 with some more complex stuff to make it suitable for BI. The most fulfilled choke points are these 2, high cardinality, group by, and joint type selection. Usually many queries ask for returning persons, so and the number of persons of the graph can be huge, so the cardinality of the group by can be large. And joint type selection. In the end, you end up doing lots of joins on properly selecting the joint type, especially because it's focused for graph systems, so might have joints materialized or indexes with the adjacencies. So properly selecting this is very important. The least fulfilled choke points, complex aggregate performance, dependent group by keys, complex Boolean expressions, which basically means if you can reorder the Boolean expressions in order to early skip the evaluation, or pattern reuse. Some queries that look for patterns, maybe some patterns can be computed based on a delta on top of the previous one. In average, 6 choke points per query. But at least a query has 2 choke points. These are the choke points classified per category. Most are related to joint performance. In the end, graph is about exploring. Graph queries are about exploring the graph and about performing joints. Look that if you sum this joint performance and graphy choke points, they add up to 44, 64, 54 probably. It's about 1/3 of the total choke points. It's good because we want a graphy workload. And this is basically an overview of the choke point table. Oh yes, and I took the opportunity to do a very quick analysis. We are talking within the workload, the task force members to reduce a little bit the number of queries. Instead of having 25, especially for those that have to implement them, it's quite a lot. Maybe we were talking about having around 20, 22 queries. So basically, if you have to remove these queries, of course, the decision will be taken based on choke points. So what I did was to compute the Jacquard coefficient between the choke point fulfilled by each query, and found that, okay, if we have to remove one query, maybe query 7, which is very similar to 15 and also very similar to 13, well, I think it's a good starting point to look at. Maybe query 7, it's a query that could be removed from the workload. So next step, take a decision on reducing the size of the workload. Probably we'll take the opportunity today or tomorrow a little bit to talk about this, and provide the new validation set for the new queries, because the ones we have are still in the old versions, and introduce batch updates. We don't want the workload to be read-only. We want to have updates that will be batch, will not be transactional or interactive. And finally, define the query mix, which is how many instances per query we run. Probably we have now the queries in the internal wiki. We don't have time to upload them in the Git, but probably during tomorrow or the next week, you will have them in the GitHub to look at them and implement them if you want, or send feedback. So thank you very much. And again, we are recruiting. So if you want to join the interactive workload, we will be very happy. Yeah.
Did you feel you might have missed some choke points?
Well,
or maybe this is also a question for Peter. Like when you guys came up with the other choke points, like how do you know you've covered?
You never know, but well, at least I mean this list started out from our analysis of TPCH, so that's already a pretty rich source of stuff.
But this was not including the graphy workloads. And actually in this process we have added two choke points in this graphy workload.
Whether the graph area is sufficiently covered.
Right.
That is a very good question.
How would we go about coming up with even these?
I mean, it would be nice maybe to have a interplay between the graph query language of people and the BI workload.
But also the graphalytics, because those
Yeah.
also be similar choke points. I think it's a continuum.
Yeah. So it would be interesting to see how you would express the benchmark.
It would be nice to actually have a unified choke point, because it's just different classes of benchmarks will hit different. All our benchmarks. It's just some benchmarks will have more coverage than others.
Yeah. What I was going to say about for GraphQL there is this list of wished functionalities, even though there is no consensus, even a full design of an LDBC query language yet. We have our wish list of the functionalities that you would want to have. It would regular path expressions, for instance. They should appear somewhere.
Yeah, in the choke point.
I mean, there are some path queries, I know.
Yes, there are.
But the question is whether just as a check.
Or like text, text, I don't know where that comes in, text indexing, or text search, and spatial.
Yes.
Now we go into features.
We are also talking with Marcus on extending datagen with geolocation information, and this will in turn repercute in
features, right? Like spatial and also temporal, right? Like temporal counting. So what's the interplay?
What do you think?
No, it's okay.
Features.
Don't think. I wanted to have this. Because now.
What do you want?
Now Marcus is here, so I wanted to put his photo.
Okay.
Arnau, did you also put that in context?
No, I didn't.
That's your WordPress, I think that's your WordPress SNB or what?
No, he dresses he dresses this way for the meetings.
Marcus dresses up for telcos.
Yeah. Exactly.
Actually, it always bothered me that Alex had the funniest pictures.
Not anymore. Now you know that every time this picture will appear. Unless Alex sends me a new one, which is funnier.
I think it's a competition.
Okay.
Yes.
About data generator and the BI workload. So currently you're using also the social network for the business intelligence queries.
Yeah.
And I was wondering if there are any ongoing projects like also writing a data generator that actually generates enterprise data. So like which occurs in ERP systems, things like that. And then because they could look very different from social network. Are there any plans to do this?
No. How was the slogan of LDBC was like a single data, a single data set for 3 workloads or something like this. So we are not planning now to change the data set. Maybe with the new data generator, with its flexibility, we might have.
The question is also what would be actually be the difference with ERP data compared to graph data? Because with graph data, you at least have like this log distribution of the values, which I think also a lot of ERP data has. Maybe you have a lot of more like, at least with some, for example, SAPs, I know that you maybe have like tons of choice or something like that. With thousands of tables that we don't have, but at least I think the expensive queries for data related, I think that should be. I don't know if it's. I think it's no question. There's a big difference between.
I mean, changing the scheme of the type of data that choke not previously fulfilled in our field. If I think that if in the end we fulfill the same choke points and the systems are stressed in the same way, which is the point on changing the data.
Pointing to the question what enterprises actually do with graph data. So that's the question. So because if you cooperate with SAP or whatever, then you should get a lot of input. I hope.
Even Oracle sometimes. Customers.
That's a very good point. So if you seem to have the input, like because you're connected to.
No, I'm working at a university, but our use case is also. And what we are doing on research on could be interesting for enterprises, but since we are a university, we don't have enterprise data, so we wrote our own generators, which is we also use LDBC for other benchmarks, but we also have our own generator. So this is why I was asking.
Well,
Marcus, exactly. What is your
I think one of the major challenges is that enterprise data as a term is already so wide. I mean, what would we consider an enterprise data graph? I mean, of course, we are covering quite a large number of domains, but I think at least for a benchmark, you have to be then a bit more specific, whether you want to cover something from I don't know, financial domain or from the healthcare domain. I mean, for them, it's enterprise data, but still, the graph itself, in its shape, and probably also in its attributes, might be totally different. So, I mean, personally, I don't think that there is the enterprise graph, and I think then it diverges into different domains.
There's also somebody from IBM in the back of the room. So the question here is, what is your perspective on the graph data in the enterprise? Is there, well, here there is social network data being modeled, but is there a big problem here, you think?
I didn't see a problem with what you described earlier. I mean, we do have data. It's not available. It creates a standard case. So yeah, I think what you've done is fine so far.
I do like the idea of multiple domains.
Multiple domains.
Because the kind of, I mean, the question is,